Good afternoon, ladies and gentlemen. My name is Aaron Stark. I'm the founder of Aaron's Arms and the lead product designer for WEquil School, a project-based self-directed virtual learning platform. This week's demo day is on mathematics. Our guest speaker today is Stacy Levin, who has many professions, including a design and creativity consultant, educator, music and vocal coach, and theater director.
Hi, guys.
Within these many spaces, she applies math, and is here today to show how math is everywhere.
Stacy, would you like to say a few words?
Absolutely. Hi, guys.
Hello.
Thanks for inviting me here today. I'm so happy to meet you all. And it's so nice to see new faces and to get to share something that I love so much. I was asked to introduce myself by way of math and how it affects my life. And I've been really thinking about this question because to me, this is very similar to saying, how do you breathe? Or, what exactly is thinking, right? It's such a big question. So I thought that I would introduce you to my life in the hopes that it would resonate with you and some of your lives. So here we go. All right, I highly suggest that we pin my table view so people can see it. Well, I started out as a baby like most of you. And as I was a baby, I liked to cry. And I learned the louder I cried, the more attention I got. Thus learning the principle of greater than, less than. I hope that you all have found the same. When I got a little older, I had a favorite food, and it was carrots. And I ate so many carrots that I turned orange, really. And I learned the concept of limits. Perhaps you all have learned the concept of limits too. That affects carrots. All right. As I got older, I really loved to read. And I learned that reading minus sleeping for me equaled not so happy. Subtraction. I hope that you all are watching this and thinking that it is halfway silly and halfway not silly, because these are intuitive feelings of mathematical concepts, right? In high school, I loved baking, but I wanted to bake for all my friends, thus having to double, triple, and quadruple recipes, multiplication. And I always have played music and played piano and singing, and there is really no greater way to learn division than learning how to read music. It's intuitive, it's physical, it's amazing. I liked doing mind benders, and I liked visiting my family on the East Coast. I'm from California, by the way, where everything's always nice and sunny, but on the East Coast, there was actual snow, which was magical, and we got changing over time. And as I loved all of these childhood things that I was doing, I always felt like there was some kind of greater principle affecting them. And when I got to the first love of my life, which was calculus, I realized that my love of changing over time was actually expressed with derivatives and calculus. And I loved that other people obviously love studying change over time also. So I went to college. My college mascot is very funny. It is a cement block on another cement block. I went to Harvey Mudd College, and there they have a curriculum where everyone has to learn everything, basically. So I learned chemistry, I learned physics, and my physics professor's favorite physics concepts were all about elephants and vacuums over time. That's why I'm drawing an elephant here. I learned computer science, there we go, a little computer, and engineering.
Hello.
Hello.
Stacy. I just wanted to say that I really like how you're learning like different math concepts by like doing and like by doing different things and learning by using and learning by your experiences.
That's exactly what I'm hoping to encourage you all to think about. So thank you so much for that feedback. Thank you. I'm going to show you.
With your experiences, were you
Yeah.
realizing that at the time, or is this kind of after the fact applying math concepts to these experiences in your past, but not but when you were little and you ate so many carrots, were you thinking about that as kind of like this is actually related to math, or was that something that you kind of realized after the fact and was like, I can actually apply this math concept to that life experience?
What a fun question. And I'm going to say that my answer is a little bit of 50-50. And the reason why I'm saying 50-50 is because I have always loved math, and I really lucked out that I had a mom who happens to be visiting us and standing right here, who also loved math. And when I was in the bathtub, we'd talk about fractions. And when I was in the car, we'd play number games with the digital clock. So I always grew up thinking about math. Now, the concept of limits, right? This one, that really shows up for the first time in a math class in about pre-calculus. But the intuitive concept of limits, everyone knows if they've experienced a Halloween where they've eaten too much candy, right? So the key here is when you run into a new math concept to really think about where you have experienced this in your life before, because I promise you have. Everything in math, and actually you hit exactly what I was going to next. In college, what I learned with studying all of these subjects together is that math is not a separate subject at all. It, in fact, is a language. It's a communication tool for all of these subjects, including logic, change over time, music, food, all of these things. But really what it is communication. Communication. There we go.
How did you get the idea of drawing out the math concepts? Because I think that's really cool how you like draw everything out and you're able to like communicate that visually.
Thank you so much. And your name starts with an A, doesn't it? It's not on your...
My name is Isla.
Isla, I thought so. I thought it was something like that. I have a friend, Eiley, so I was hesitant to say Isla. Isla, that is such a great question also. So let me fast forward. Let me go to 2 more pictures and I'm going to tell you more about that. Is that fair? All right, cool. So I graduated with a degree in math because I loved math so much. Oh, by the way, this is my garbage truck because my senior thesis was actually figuring out with a team how garbage trucks could do routes where they would start at their depot, go pick up the garbage they needed to, and then go to the dump and get back to the depot using as little gas as possible, which was a totally fun and interesting real world problem to solve, don't you think? Because everyone knows about garbage trucks. All right, so after that, and Isla, I'm gonna get to your question, I went and worked for a company that your parents might know very well called FICO. And FICO does risk analysis. What that is they're trying to figure out risk. Basically, they're going to predict risk. So what they used to do it for insurance, but they mostly do it for credit cards now, but maybe other things too. But what they want to know is if someone gives you a credit card, will you pay them back or will you not pay them back? That's kind of an important question that banks really do like to know the answer to. So what I learned at FICO was when you have a big population, in order to make fortune-telling predictions that actually work, and by the way, they're pretty darn good. I mean, who would have thought fortune-telling and math go together, huh? what you have to do is segment your population into small segments until they make some kind of predictive curve like this. You guys may have seen, some of you may have seen this as a normal curve where most of the people are gonna do this, right? Whatever this is, most of the people are gonna do this. And then this particular curve has some important ideas that happen as the tails go further out. But the most important thing to know is that most of the people in this curve do this, all right? And when you add up a bunch of things together, like if you say, well, let's see, I have a son, he's 7. So let's say my son Eli was applying for a credit card and be like, well, he's 7, he doesn't have a job, he lives with his parents. I'm pretty sure if we hand him a credit card and he goes and buys a car with it, he's not going to pay us back, which I think is a pretty fair assumption at that point, right? So when you add up all of these points about someone, you get a fortune teller ball, which was pretty darn amazing. But the thing is, and Isla, to answer your question, I was not terribly passionate about figuring out whether people would pay off their credit cards. And some people are, and that is awesome, but that was not me. So I decided to go back to school. And I went to Stanford, which has a very small master's program that is about product development and design thinking. Design thinking. And I wanted to combine more of what I had seen in my life through communication, math, and also prediction, because I thought the fortune telling part was pretty darn amazing, right? I mean, who doesn't want to be a fortune teller? So this program encompassed a lot of those things for me, where they taught us different forms of communication, like drawing out your ideas, which I thought was pretty darn great idea. And a lot of designers like to do it. And the crazy part about Stanford that I was really surprised at is when I learned how people needed to do research to design new products and services, what did I find? I found the same curve I had used up here doing credit card research and predictions. And I was like, what? That's a crazy coincidence, right? So far, all these things have been so different. And now I find the same thing. But here was the crazy part. When you want to figure out what a bunch of people are doing, you want to look at the top part of this curve. But when you want to figure out what the next thing to make is, and I know that some of you are designers yourself and inventors, here's what you want to look at on this curve. You want to look at this side and this side. These are called extreme users.
That's a normal distribution, right?
It's supposed to be. It's not, my drawing is not perfect. Yes. But these are your extreme users. Let me give you an example. If you were designing, well, actually, I hear that someone around WEschool is interested in smoothies, right? So if I were going to give advice to someone who's designing smoothies, I might say, go talk to people who, here, we'll go, it's right here. Go talk to people who drink smoothies 3 times a day. Go find the smoothie lovers around you and talk to them about what they would like in a smoothie service. And then go find people who do not drink smoothies. No to the smoothie. No smoothies. Because you might learn something from both of these populations that would fit these populations. And even though you're going to sell the most smoothies in the end to these people, because this is where you want to be with the most people and the most sales, these people and these people are going to inform you about these people. Does that make sense? Oh, by the way, this one up here that uses just the math is called quantitative analysis. Quantitative. And this one down here also uses some concept of math, but when you go out to the extremes like this, they call it qualitative analysis. And a lot of people will actually tell you they're not using math at all, but as you see, they are.
I have a question.
Yes.
Would you also talk to the people in the middle about the smoothies?
That's a good
you
question.
mainly want to talk to them because they're the customers that you're gonna want to be targeting?
That's a good question. So it is a little bit more complicated than what I'm telling you. And there's actually segmentation involved with doing design thinking research. Okay, so you might want to segment your population into kids who are purchasing smoothies through their parents versus parents purchasing smoothies on their own. Does that make sense? So you might segment your population, and then within those populations, you might speak to extreme users. But the reality is inventing and design is an art as well as a science. And the thing with art that really gets you, the difficulty with art is that it's never finished. Have you noticed that? Have you noticed that when you're like making a picture and you make the picture and you're like, oh gosh, I don't know, I feel like I could add one more thing to it and it would be awesome. And then you do add that thing and then you're like, maybe it would be nice if I put it in a frame. Have you noticed that? That art just, I'm looking for like nods here. Or like, no, I have no idea what you're talking about. But yeah. So qualitative analysis could be put in the category of it's never over. And if you talk to a bunch of people in the middle here, you can keep talking to them forever. That's kind of the catch with it. And you may come up with some things, but you're going to find those insights faster with extreme users.
Yeah, it's also with Paul Graham from Y Combinator. He's saying like you should look at the extreme people and to try to ignore the middle and things like when you're first making your minimum viable product, then the people who really like your product, even when it's not that great, you should really focus on those people and to try to make them even more happy, because once they're even more happy, then they're going to start telling other people, and then that's when you can try to reach a network effect.
That's fantastic. Yeah, there are a lot of reasons to talk to extreme users over the middle people. I was specifically addressing the question, can you get any insight out of talking to the middle people? The answer is it will take you a lot longer. And that's why I related it to art, in that you can just keep talking to them, right? But if you talk to the extreme users, there are fewer of them to speak with in the first place. You have to sometimes look harder to find them, but once you do, you'll get a lot more insight. Yes. Antigone.
How do you know you'll capture the opinions of the middle people, since they're the majority, by just talking to the extreme users?
Really, really good question. There are a lot of answers to that question also. And one of them is people have used this for a long time and it works. The other answer is, and let me think, is there a project that you're particularly thinking of or working on?
Not really. It's just, it seems like you're missing, when you use that strategy, just looking inwards from it from an outwards point of view, because I've never done anything like this. Yeah. It seems like, that's like 68% of the population, but you're missing. That's the majority.
So let me, that's so funny. When I was, Antigone, you froze, but.
That's what you want. You're frozen.
Okay.
That might be me.
So I think that this is the very, very important, Ben, I'm going to get to you in 1 second, but the very important thing to remember when it comes to this kind of work is that this is a continuous scale, right? So we might have extreme users and no users, and you may be, talking to these people, but these people are very close to these people, and these people are very close to these people, and these people are very close to these people, right? And it's a continuous scale. It's not a discrete scale. I almost did my entire talk today about continuous versus discrete because it is so important a concept. Oh my gosh, please look around your lives and think about things that we think of as discrete. You know what discrete means? That means like, if I were graphing them, they'd be like separate points. This is what discrete looks like on a graph. But it really just means separate, right? So the thing is, here's another answer. If these people do have completely separate needs than these people, then you haven't segmented your population correctly. then these people should have been segmented off into another population. And designers really like to segment populations into fours. And I think, again, this is because of time and money, because you can segment into so many different ways, right? But, right, so like you might come up with 2 scales here. I'm just going back to the smoothie model, and I just thought of one off the top of my head, which is the age, right? Age, right? So let's say these are younger people and these are older people, and you would segment them based on preferably quantitative research about how people drink smoothies. Like if you went to a Jamba Juice, I'm just going to go with the smoothie example because we're on it already. If you're going to a Jamba Juice and you say, hey, have you noticed any like really differences in your population? They might be like, oh, well, kids really like sweet smoothies where adults tend to go for healthy smoothies. That might be for you a point where you might segment your population, all right, into younger and older, right? And then you might segment you probably wouldn't do sweet and healthy because we've already kind of segmented for that here, but you might do something, I don't know, like fun flavors like bubblegum and chocolate versus green. I don't know. I'm just throwing it out there off the top of my head. Really, I'm not a smoothie expert. But when you have these segments, then you would go into these segments. Oops, oh my gosh, what is happening with that curve? It's really hard to do normal curves over people's heads. And you look at the extreme users there. And that's why I say in business, also time is money, money is time, right? Now we're looking at 8 segments. That's going to take you a bunch of time and a bunch of money if you're hiring people to do it for you, right? So this is probably a limitation of what companies do now because of company limitations. Again, going back to limits, look at that. Those carrots came in so handy so long ago, right?
I have a question.
Yeah.
Yeah. I'm wondering if, like, you're saying that you should ignore all the people in the middle, but I think you should ask like everyone and just keep the data on who you're asking.
That is fantastic. Oh, that would be fantastic if so. So if you know that you need to come out with your next version of product in a week, okay, and you know in that week you're going to have time to talk to 20 people. Here's the question: do you just walk down the street and talk to your 20 neighbors, right? Or do you go looking for 20 people who might fall like 10 on each side of this? And I say you're probably going to get better insight into your product if you find these people on either side. It does take more work to find them. Now, that's assuming that you can only talk to 20 people. If you can talk to 40 people, you could spend time looking at these 20 people and also go talk to your 20 neighbors. It's not like you're not going to find anything out through your neighbors, but that you might find the same things faster through the ends. Ben, talk to me.
Well, if you're talking to the people that don't really like smoothies,
Yeah.
well, they've probably not had that many smoothies if they don't like smoothies. So
well, you know what? Look at all the information you would have gotten just for that. What would be the next follow-up question if you found out that they don't like smoothies because they haven't had smoothies? What are some questions or some ideas for your product you can come up with because of that? Can you think of any?
like maybe try and make smoothies that the people that don't like smoothies would like.
So maybe you could ask them what they're drinking instead of smoothies.
Yeah.
So that might be a next thing to help you design for your smoothies. And also, maybe you could find out that they don't drink smoothies because there's not a smoothie place local to them, or maybe they're too expensive for them, or other things that could inform your business. What if you gave them 5 free coupons for your smoothies and they had 5 smoothies from you, and then you're like, then those people were like, I'm a smoothie convert. I love the smoothies now. I'm going to give up my Starbucks and go to smoothies. You just got yourself some smoothie users from extreme left to extreme right.
Also,
that make sense?
on your point of like getting people to like asking different and in research, Isla actually, we conducted a survey and we went around in our neighborhood we were doing a research project on plant-based meat. So are you done with your prepared remarks, Stacy, or should we move on to Isla?
Well, I can be done. I can be done because I can just walk on this forever. I was gonna tell you, and I'm just gonna write some things down for you guys to just look into later. So the other things I was thinking of are things that I love that I just wanted to share with you in case you guys are like totally jiving in this and you're like, I want to go do this too. All right, you gotta go look at Andy Goldsworthy. There's a movie. He's an artist. And he makes art that has everything to do with change over time. And man, I'm going to tell you, if you haven't hit calculus yet, it is the most beautiful thing you've ever, I mean, I don't know if you cry when you hear symphonies, but if you look at calculus, if you don't cry with joy, you got to go find yourself a teacher that's going to explain it to you like that, because it is the most beautiful math in the entire world. Andy Goldsworthy, you got to go look at a gem cutter, Weinsteiner, who is a guy who believes in finding the intrinsic patterns in the gems before he cuts them. It's like an amazing work of art. And John Edmonds, he's actually out of Stanford, and he makes math-based art that's in the Museum of Math in New York City. If you can get there, it's super fun. So I'm going to tell you about that. And the crazy thing is, I use all of this now when I'm not doing design thinking, consulting, and stuff like that. I also use math to direct theater and compose. But I think we're going to have another conversation about that because, you know, we could just go on this forever. So we'll talk about that next time. I want to hear what you guys are.
That's great, Stacy. We can also continue this after the project. So
All right. So I think we're going to go to our first presenter, Isla, and on her presentation on the rise of plant-based meat. So take it away, Isla.
Hello, everybody. I am Isla McPhail, and I am 9 years old. And today I will be talking about the rise of plant-based meat. And my family made a video, and the video is about the research that we did on plant-based meat. We made a survey to get more information about plant-based meat and to see who liked real meat or plant-based meat better, and over time, how did that change? One of the things that we noticed was that people liked plant-based meat better until later on, when we were going around the neighborhood and giving out taste testers to get what everybody thought about it. The less fresh the plant-based meat was, the less it tasted good. Also, we based this a little off age to see how young the people were and if they liked it better or not as much as the real meat. One thing that I really liked about this project was that we were able to go around the neighborhood and use math in our life, and while learning more about like the rise of plant-based meat and making different surveys. So that is an example of how you can use statistics in your life, is to do surveys and to look at data and to learn more about the world.
That is so cool. I love it. And that is, by the way, a fantastic use of looking at a regular normal curve and finding the median here. That's a great use of it. No need for extreme users in this kind of sampling. So that's fantastic. What interesting.
Yeah. For conclusion, I think that it's really important for people to realize that math is not just something you learn in school and then never use in your life. It's something, the reason why we learn math is so we can use it and apply it to learning more about the real world.
Love it. I mean, absolutely fantastic. Great analysis. Now, see, the other thing about communication is that communication is power and math is power. What do you want to do with this information? You can use it for good, for evil, for design. What are you going to do?
Sorry, I didn't catch that. It glitched out for a second.
Oh, sorry. Well, I was saying, now that you have this insight, what do you want to do with it?
Well, the reason why we wanted to learn more about plant-based meat was to help us learn more about, is the future really plant-based meat, because or is it healthier, because one of the things we found out was that it was actually highly processed. So maybe not highly processed foods are more healthy, but it's definitely better for the environment. And so we wanted to use this information to we wanted to use this information to help us figure out what the future is for that. I think that's one of the main things. And I'm wondering what Antigone's question was.
I have two comments. The first one was, I was wondering how large your sample size was.
Oh, well, I think it was like about the size of the meatball.
Oh, I mean, how many people did you ask? Like, you made them try the plant-based meat and then the regular meat. How many people did you ask which one they liked more? How many people did you talk to?
I think it was around 20 or 30.
Yeah, because we just went around the neighborhood. Went around our neighborhood, yeah.
Got it. And my other comment was, one of the ways you could use this information, or well, if I were to conduct this study, is if you shared it, people might be more inclined to try plant-based meat, and it could be helpful for the environment.
Yes, so that's why we made the video. So we made a video on that, sharing our thoughts on it and showing like the effects on the environment and talking about the pros and cons of plant-based meat.
And also, if you, in the description of the Facebook Live and the YouTube video, we have a link, and if you go there, you can see Isla's video and all of the projects that are being presented today.
So Isla, I just want to point out that one of the topics that you just brought up was multiple variables, right? So in a very elementary way, you just described this, right? So, I mean, multiple variables come up in all sorts of math, from basic algebra to multivariable calculus, right? But you have a bunch of different factors, which we can call different variables. And then you came up with some kind of conclusion at the end of that video that I'm very interested to know what your conclusion was. Should we go to plant-based meat? Do you have recommendations for restaurants who serve plant-based meat? If you're going to throw a party, what would you do? Right? Multiple variables. Very cool.
Are you asking me about like, what do you do with the information on?
Well, math is cool because you can use it and just be like, oh, that was cool. Or you can use it. Like, from what you're telling me, if I was going to throw a party, I would make sure to not cook my plant-based meat hamburgers in advance. Right? I'd be like, okay, so if I wanted to plan a party and I didn't want to cook during the party, plant-based meat may not be the right choice for a party food. But if I was going to throw a barbecue and I was going to stand outside of my barbecue with my friends, then plant-based meat might be a fantastic option because they're going to eat it right off the grill, right?
Yeah, that's a great example that's a great example for this with using that information to help you, and I mean that I think that's that's one reason why you can use this information.
Very cool. I love using the information.
Because it's one thing to just learn it and never use it, and the way you can retain it and remember those things is if it's actually useful in one, two, or more ways.
I agree. You know, one thing I would add to your chart, your graph that you showed, is you didn't have a scale on the bottom from fresh to not fresh, your freshness scale. And you left me wondering, gosh, was that a 5-minute scale? Was it a 5-hour scale? Do you know what I mean? So I might, as just a note to, improve for next time, I might really concentrate on marking your scales. Does that make sense?
I don't exactly get what you're trying to convey right now.
Can we pull up your
I'll share my screen. At the bottom of the chart, at the bottom it just says very fresh, freshness, not as fresh, but I think over here it says preferences for plant-based meat dropped off about an hour. So right around here is an hour mark.
See, I did read that, but I couldn't figure out whether the hour was all the way at the not as fresh side or whether it was the first drop off that we see, like down here still above the S of very fresh, for example. So anyway, noting your scale is pretty useful when making a graph.
That makes sense.
Cool.
All right. I think we are going to give it up to the next presenter, Antigone, and she's going to be presenting her birthday problem project. So take it away, Antigone.
I think we're gonna first show her video.
All right.
Hi everyone, my name is Antigone Stark, and I am currently a student at Makeshift Homeschool. Today I will be talking about the birthday problem. I read about it in this book, 50 Mathematical Ideas You Really Need to Know by Tony Crilly. I highly recommend this book. There's a lot of good stuff in here. But if you're looking for more information on this problem specifically, the internet is an excellent tool. So the birthday problem states that if there are 23 randomly chosen people in a room, there is more than a 50% chance that at least 2 of them will share a birthday. For most people, this is pretty surprising given that there are 365 days in a year, which is a lot more than 23. So in this room, there are only 2 possibilities. Either there are at least 1 pair of people with the same birthdays, or everyone has a different birthday. Since these are the only 2 possibilities, their probabilities must add up to 100%. So the probability of having at least 1 pair plus the probability of having all different birthdays is 100%. If we rearrange this equation to make the probability of having at least 1 pair the subject, then we get the probability of having at least 1 pair equals 100% minus the probability of having all different birthdays. We will start by solving for the probability of having all different birthdays, because that way we won't have to solve for each case of people with pairs, because with the probability that they're all different, each person just has 1 case, which will make sense as we continue this video. So here are all my 23 people. If we take 2 people out, Billy and Bob, what is the probability that Bob has a different birthday than Billy? Well, Billy's birthday lands on one of the 365 days of the standard year, which would leave Bob with only 364 days left. So the probability is 364 out of 365. If we add another person to the room, Joe, what is the probability that Joe has a different birthday than Billy and Bob? Well, we've already established that Billy and Bob have different birthdays, which means they account for 2 days of the standard year, which leaves Joe with only 363 days out of 365. If we continue this sequence until the last person, the 23rd person will have a 343 out of 365 chance of not sharing a birthday with anyone in the room. The next step is to multiply all of these probabilities. This is because we're looking for the intersection, which means that each one of these statements is true. So if we multiply all of them together, we get 0.4927, or 49.27%. And if we recall the last equation, the original equation we solved for, 100% minus the probability that they're all different equals the probability that you have at least one pair, we can say that 100% minus 49.27% is 50.73%, which is just a little bit more than 50%. Thank you for watching.
Stacy, do you have any thoughts or words for Antigone?
Well, I just have a big smile on my face because this is just one of the things I love most about math is that it can be surprising and it can be beautiful. I mean, isn't that beautiful? Antigone, did you find it beautiful? Isn't it just so cool? Oh
Yeah,
my God.
my intuition was all wrong. I didn't believe it when I first heard it. Well, it wasn't an original idea. I think it was from a while ago, but when I heard it was only 23 people, I was like, yeah, that's not right. And then I went through the math and it actually was right. So that was interesting.
It's beautiful. That was a beautiful proof. It was presented beautifully and artistically. So that really appealed to me. There are two things that I think that you would really love looking into if you're into this kind of math. One is game theory. So this is a very small example of game theory. It doesn't exactly relate to gaming, but the math is very similar. And I think you'd just really dig it because there's a whole world out there of probabilities that are surprising with rolls of dice and cards and other things. And there's some really famous game designers. I'd have to consult my expert gamer, which is my husband, who utilize game theory to actually create their own games that are spectacular. And there are actually worldwide competitions for game design. Anyway, you could just take this and run with it as far as you wanted. It's so cool. The other thing that struck me, if you like this kind of humor, and I consider this math humor, is there's a book called Predictably Irrational, written by a guy out of MIT's, I think it's their media lab, but I'm not 100% sure about that, but it's definitely MIT, about human behavior. And, you know, you started off by saying you didn't believe it, and no, like, who would believe this, right? And it's about human behavior and how sometimes our instincts don't make rational sense, and how that's funny when you compare it to the math involved. So if you enjoy that kind of humor, you'd really like that book. I think this was fantastic. I hope you really enjoyed it.
Thanks a lot. Thank you. I'd like to check that out. That sounds interesting. I was also doing some research on Wikipedia about this problem, and it says that humans are pretty good at identifying things when the scale is linear, but once you get into exponents and above, it's hard for us to picture that in our brain. So that was interesting to me.
Indeed it is. That's fantastic. Yep, I love it. I'm so proud of you. I just met you. It's amazing.
All right. yeah, I thought that was really cool. And at first I didn't believe it, but then as the math came on, it kind of made more sense to me. I think we're going to hand it to our next presenter, who is who's our next presenter? Benjamin. All right, take it away, Benjamin.
So I'm talking about exponents, and basically exponents are just repeated multiplication, and also like a way that you can use exponents in like the real world. If you're like maybe you want to code a game that's like a zombie apocalypse, then it starts out with 2 zombies, which get an extra, which like zombify 2 other zombies, and now it's 4, and then those 4 zombies each zombify another zombie, and so now it's 8, and so on. And so you can do the same thing if it starts at 3, and they're each zombifying 3 zombies. But I mean also like with viruses, like if you want to use COVID, then like COVID probably started off with 3 people that had it, and then they gave it to 3 other people, and then those 6 people each gave it to 6 other people, and so also like instead of just doing 3 times, and they can be helpful, so instead of doing 3 times 3 times 3 times 3 to do whatever 3 to the power of 4 is, you can just do 3 to the power of 4, and so on. And so like exponents like get high really, really fast. Like in this post it says just 6 to the power of 4 is already in the thousands, 1296. And so like I don't know why, but when I was like 5, I just randomly memorized 2 to the 17th power, which is in the 130,000s. So
Ben, that was fantastic. Exponents are so incredibly useful and beautiful. I love the zombie apocalypse example. Honestly, I don't know why in the history of my studying math, people don't use that all the time. Like that makes the most purest sense of a zombie apocalypse. I can go back to my math professors from college and tell them if they're doing elephants in physics, they should absolutely be doing zombie apocalypses in math. That is incredible. If you want to continue to explore this concept further of virus spread specifically, you and Antigone should get together, because I loved your example of COVID. And also, let me explain, there are multiple ways you can do mathematical modeling. So mathematical modeling is to basically take some kind of natural phenomenon and basically chart it as a graph, right? So if you go back to my paper for a second, like I could sample something and it could have just kind of a straight line, right? If I'm just gonna look at one variable, like maybe, but as I start adding more complexity to it, I might realize that that model was a little bit off. I don't know, can you see that, right? Like I might notice that my model was wrong at an extreme end, or I mean, possibly in the middle, right? And as I get more into the details and I make my predictions finer and finer, I might even notice that at the end, right, it might have a significant difference. I don't know if you can see that, right? So it might go down. So right now, if we were going to use your model of the prediction of COVID, you have kind of one thing going. You have the exponential growth, which this is not exponential growth, this is exponential growth. But I mean, this is the model that you have going, right? But as it turns out, there's a probabilistic factor to virus spread, right? I mean, it really matters. Are you in the room with the person? Are they masked? How far away? How long are you going to be there, right? And that is what makes this COVID prediction stuff so hard, right? You may be like, well, I'm looking at exponents and I understand virus growth. Like I'm looking at the New York Times, I'm looking at the greatest research institutes and, you know, the universities of the world, and they seem to not be doing a very good job with this prediction of how COVID is going, right? Why are they not doing as good a job as they should be or could be, right? The reason goes back to there are so many variables, so many different things affecting the spread, right? So I think the next step for you would be to add probability into your exponents for your virus modeling. I think you're going to find it really cool. I think it's fantastic work, though. Zombie apocalypse is going to stay with me forever. Antigone, tell me, yes.
I thought this was kind of relevant. At the end of the year in my statistics course last year, we did a project which was COVID stats in the news. And there's this one group, I think it's based in Seattle, but it said that we were like way underestimating the amount of COVID deaths by at least half. But then it turns out people did a little research into the study, and they were taking information from places with high testing rates and applying them to places with very low testing rates. So no one knows for sure, but it seems like their results could be really inaccurate due to extrapolation and stuff. But that was interesting to me.
If I can encourage you all to do one thing for the rest of your life, when you read a number in the news, in research, in whatever, you have to go look at two things. One is sample size, okay? The other one is who they sampled. It is extremely important. Numbers can be extremely misleading. And that's really hard for someone who is math fearful to understand. There are a lot of math fearful people out there, and they're just like, oh, it's a number. Okay, I'll just accept it, whatever it is, right? It's hard, man. I have read things in the news lately that this Delta variant gets through vaccinations anywhere between 40 and 64%. That's a 25% swing out of 100% total, right? I mean, the prediction is incredibly bad. And it's very, very difficult to determine what an honest number is. I think that the challenge for your generation to come will be to figure out truth. And truth in numbers is going to be a big part of that. Sample size and who they sampled.
Yeah, I definitely agree. I once saw a graph about, I think, gun deaths in Florida. And since I think it was a new law that passed that allowed people to open carry or something, and the graph went down, and it was really misleading because it looked like the amount of gun deaths went down, but then you saw who was funding the graph, and it was people who were trying to get the gun law passed. And then you actually looked at the numbers on the side of the graph, and they switched the numbers, so it was actually going up, but it was tricking a bunch of people into thinking that gun deaths were going down.
Right.
So yeah, I think there's definitely going to be a lot of problems with the truth, especially with social media and a lot of things that can make false claims.
Yeah. And to add to that, very, very astute point, the idea of correlation is incredibly complicated. There are some really fun websites you can go to that correlate random things. Like it might be a correlation between gun deaths in Florida and ice cream cones sold in California. And because of the scale and the sample, you can create charts that are unbelievably similar. And and it's a hilarious website. It's supposed to be funny. But the concept of correlation and cause and effect is very complicated. And we need more people like you guys who are interested in math to really study this and preach this understanding of math. Fantastic. Yep.
All right, I think we're going to have our final presentation. Sume here. She's doing a presentation on a utility function. So go ahead.
So this is one conversation we were kind of having on not really just the function in general and like how you can calculate utility, but also a mental model and how you can think about utility and how and the definition of utility that I'm using within this article is happiness. And so it's like how to think about happiness and how to think about how you can be more happy in your life, but displaying that through a calculation and through math. So this is, as Stacy was saying before, there are so many different variables and things and so this is a very, very simple way of calculating math that is that doesn't have everything in it, but it's just it has your utility, and basically the purpose of this is that you're supposed to be trying to maximize your utility or happiness, and it's like how much happiness you gain from something but gain from something that is bad for you, like eating something unhealthy, and then amount of that bad thing that you did that was causing you happiness. So then you multiply those plus how much happiness you gain from something that is good for you, multiplied by the amount of thing that you're doing that is good for you, and then plus your baseline happiness. So that's one calculation that you could use to calculate your utility. But then from that, there are different strategies you can use to maximize your utility. And the first one is called get more stuff, and it's basically the two variables that you can change is the big B and big G, which is how much good and bad things that you can do to gain happiness. And so within this strategy, the way to maximize your utility is by eating more unhealthy foods, but also doing good things that are good that make you happy, like hanging out with friends. And it's basically just do as many of these things as you can. And that's how that, and within that strategy, when you're only affecting those two variables, that is how you can maximize your utility. And the downside to this is it's incentivizing you to do things that might be bad for you, but it makes you happy in the short term, but has long-term consequences. And so that leads to the second strategy, which is changing preferences, where the variables that you're affecting is how much happiness you actually gain from these things. And which is a very interesting way of thinking about it. And that's something I mentioned in the article, is like, usually you're not thinking about when you're playing with your friends, maybe I can be even more happy if I appreciate this more and I live in the moment. And so although you might still be doing bad things, it's like maybe you eat a cookie, but then you're just so much more happy from just eating that one cookie. And that's one way of thinking about maximizing your utility. And the third strategy, called meditation, is where the variable you're affecting is your baseline happiness. And so there are multiple ways you can try to increase your baseline happiness. It's also, people's baseline happiness is different. Not everybody just feels neutral. Some people might just be naturally more happy and bubbly, and so one thing you can do is meditation might be one way to try to raise your baseline happiness, but it's also just like getting more sleep and eating healthy foods and things like that to increase your to increase your baseline happiness. And so this is more of like showing a mental model of how you can increase your utility and how to even think about what makes you happy and how and what makes you unhappy, and how does this and how is this affecting me in my life. But it's one way to display things is you could just say you should try to be more happy, but then by showing it within a calculation and within this function, it can make things more simple and more intuitive in your own mind.
That was just wonderful. And what a great use of math as a communication tool. And humorous and positive and useful. So, I mean, that was just beautiful. What were your conclusions from that?
Yeah, well, I think you can one thing you can do is like just implement all the strategies and then try to increase all of the variables, but thinking about I think a lot of it was just that you can affect these variables. Some people aren't just like, oh, my baseline happiness is that I'm always sad all the time. And it's like, no, you can actually try to change that. You can actually try to change how much happiness you gain from doing things. It's not just, okay, cookies make me happy, I'm just going to eat a bunch of cookies. And it's like, well, maybe if you eat one cookie, you can just really appreciate that some people don't have access to cookies, and that's not something that's available to them, and then that makes you even more happy. And that's and it's interesting just to think about how you can apply that and what and how you could be more happy in your life. And it's obviously you can't always be happy because you have to have negative emotions sometimes, but you do have some degree of control over it.
That's such incredible insight for someone your age, and I love that so much. I think that you have successfully modeled additional concepts like why dieting often doesn't work. No, fewer cookies, smaller happiness, right? And why so many people have been depressed over this time of COVID, fewer friends, smaller happiness, right? This kind of modeling is exactly what FICO uses to make credit card predictions and what many other people use to make predictions. I would encourage you to add to this more complicated functions instead of linear ones, right? So right now you have more cookies, more happiness, right? More cookies, more happiness. That's what that looks like. Cookies and happy.
That's
right?
also something we were thinking about. Is I didn't have time to add this to the article, but but my family was thinking about how you can use calculations, how like let's say happiness from bad things, and then how that has that over time, you're like that's gonna probably like a month from now, you're probably gonna feel bad about eating that cookie, and you know that wasn't really the best for you, and how maybe like just your happiness from your entire life, how that's gonna have consequences on you and your happiness later on. And so yeah,
and this is actually why and I didn't mention a bunch of other things that I'm interested in, but I also got a minor in psychology in college, because when you start looking at logic and psychology together, it is so incredibly complicated. And this is why we do not have a secret of happiness. I mean, right? Because you can make this as complicated as it could be, right? You can use supercomputers to calculate so many functions and variables, and you will never find every variable and every outcome. And then what you end up getting is a probability range, right? So, I mean, ultimately, even if I made this, so, just, cookie example, right? I'm happy with 1 cookie and happier with 2 cookies and happy with 3 cookies, 4 cookies is fantastic. Then I feel real bad afterwards, right? I mean, and I'm just talking about an immediate effect, right? Or maybe it's like at 3 cookies, I plateau and 4, 5, and 6 are pretty good. And then it goes down, right? So, I mean, you could talk to parents and doing some kind of, major mathematical experiment of how many cookies it takes to make you feel real ill. That would be a fun experiment, or not. But it gets to be incredibly complicated because you're looking at now, you can look at later, you can predict, well, I'm going to be happy now, but not happy later. And then people have to make their own choices, right? So what's the probability of me being happy now and happy later? What's important to me, happy now or happy later? All of these things are very clear when you're a credit card company wanting to get your money back. What's important to me is getting my money back, right? What's important to you in finding happiness is not as clear. But these things can be weighed and calculated on every aspect of your life, from the probability that you will end up being happily married to the person who you choose to marry now, and then looking at that like, well, in 50 years, do I predict that this is the person who I'm going to be with? I realize y'all are way too young to think about things like that, but you could model things like that, right? But it all goes back to probability, which is just a really fun and fascinating subject. And I highly encourage the math psych double interest. And I saw that you guys had a psychologist present. So
it's also really cool how like something like just a happiness model, because also in your first when you were first talking about how you were like calculating things at the company that you worked at, you were seeing this model, and then you were working somewhere else and you saw the same model, and you're applying the same concepts, and you're applying something that you're applying this concept over a bunch of different things that people don't really see them as really related things, but you're still using that math concept in the same way.
Using them in different ways, but yes.
Yeah.
Right? I mean, it's so interesting. You're able to pick and choose with math, which is really powerful too, and combine. So this was so inspiring. That was awesome. I love it.
Isla, do you have a question?
I think that we talk about all these different things at WEquil School.
I am so happy to hear that. That's amazing.
All right. Is there anything else on the agenda to do?
I think we probably don't have time for a question answer session, but yeah.
All right. So should I have a good day, everyone?
Thank you so much for joining, Stacy.
Yes.
Oh my goodness. Thank you. I'm going to walk around on a cloud the rest of the day from all this inspiration. Thank you all so much.
Thank you. Bye.
Bye.
Have a good day.
Bye.